Alright guys, today we're working on 5.3a, which is converting radicals to rational exponents, and 5.3b, which is converting rational exponents to radicals. So we're going from radicals like we have been, square roots to rational exponents. We're going from rational exponents back to radicals, and that's all this part is for a and b. We'll do a separate video with c, which is simplifying, but this is all it is, just going back and forth right now. So we're used to doing some radical and some exponent stuff already. We'll talk about what this rational part is in a minute. We're used to doing some exponents. So let's review what we've got. So if we got like a to the m power, that's kind of like saying 4 to the 4th power, which is 4, of course, multiplied by itself 4 times. So that's 4 times 4 is 16. Another 4 times 4 is another 16. So 16 times 16 is 256. So we could say this is really just whatever a is, whatever that base is, multiplied by itself m times. And there might be a whole bunch of them, so I'm just going to write this dot dot dot. So multiplied by itself m times. So multiplied, multiplied, multiplied. Okay, so then we've also seen this negative exponent. We've seen that if we have something to the negative exponent, that's like maybe like 3 to the 4th, which is, by the way, 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So 3 to the negative 4th is 1 over 3 to the positive 4th, which is 1 over 3 multiplied by itself 4 times, which is 81. So the easiest way we can say for our rule for negative exponents is we take whatever it is, we put it in the denominator, our base, and then to the positive exponents. So 1 over whatever that is. So then when we say rational exponents, that's saying when we have a ratio, so rational, the root word is ratio, we have a ratio in the exponent category. So this is something like this. So this is saying, like, what happens instead of having a negative, instead of having a positive, what happens when we have a fraction in the exponent? And this is, let's just think about it in terms of 4. So like 4 to the 1/2 is the same as saying the square root of 4, where we have this bottom number is our, what we call our index for our radical. And square
so multiplies by self 2 times to be 4, which we can simplify this. We know how to do that. The square root of 4 is just plain old 2. So if I'm looking for like a generic rule for all of them, so if we have a rational exponent, which is a ratio in the exponents, that says that we can rewrite this as the radical of the root, which is a, to whatever this power is, whatever this thing is right here, which is right here. So basically, the shortcut is that we take the a, we put it on the inside of the radical, whatever that denominator is, we put it as the index. And so this would say it multiplies by self m times, where we've seen 2 quite a bit, and 2 is that number for square roots we don't have to show. Okay, so all I'm asking you to do with a and b is just go back and forth. We don't need to simplify or anything. So we're just going to convert from radicals to rational exponents and from rational exponents to radicals. So if I say 8 to the 1/2, we can just say, oh, that's 8 as our base, and that's a square root because we have a 2. And yes, we can simplify, but for this, I know we can't simplify this one. I'm probably going to try to give you things that you can't necessarily simplify. So that way, it's just, I'm just practicing, can you go back and forth with this? Okay, so example 2 is 5 to the 2/3. So one of our properties of exponents we didn't talk about up here is that if we have an a to the n times a to the m, then that's really a to the n plus m power, which is just basic multiplication. And then we also didn't talk about if we have exponents raised to the exponents. So if we have something, let's just say like 4 squared to the 3rd power, then it would be 4 squared multiplied by itself 3 times, which is just going to be 2 plus 2 plus 2, which is 4 to the 6. Or we can just get 6 from 2 times 3. So a to the n to the n, a to the n, all to the m power is just saying a to the n times m power. So we're going to use that and kind of go backwards to rewrite 5 to the 2/3 as 5 squared all to the 1/3 power. So we're just going to rewrite it because 2/3 is the same thing as 2 times 1/3. So I get rid of my fraction on the inside by bringing my denominator to the outside, and then 2 times 1 gives me 2. So then I'm going to rewrite this using our rational exponent rule. So we have a 1 in the numerator. We're just going to take that denominator, put it in the radical or in the index, and put whatever is being raised to that power on the inside of that radical. So this is really the 3rd roots of 5 squared. And that's all we have to do to it. Okay, let's go backwards. So this is A, which is going from, actually this is B, which is going from rational exponent into radical form. So we started with our ratios in the exponent, and we ended with radicals. Let's go the other way, so let's do A as well, which is going from radicals to rational exponents. So square roots, we've seen these quite a bit. We know that we have to find something that multiplies by itself. That's something that multiplies by itself, which is 2 times. So anytime you see a square root, you can go ahead and put a 2 there. So we take our base, we're going to take our base with our root, and we're going to convert it backwards. So my base is 5. I have a 2 in the denominator in my exponent, and be very careful to make sure that you write it, and so I can very clearly see this is not 5 1/2, but 5 to the 1/2 power. Okay, example 4, do the same thing, except our index is different. Take our base, whatever our index is, goes in the denominator of our fraction in the exponent, and we are good to go. And that's it. That's all you have to do. So take your base, do that. All right, so example 5 is kind of like example 2 in that we have a couple things involved. So let's just do the conversion with our rational exponent rule, which says that we have 2 to the 3rd power is our base, and then our root number is 8, or sorry, our index is 8. So we're going to have 1/8 up here, and then we need to multiply these two to simplify just a little bit. So 3 times 1/8 is 3/8. So we're going to have 2 to the 3/8 power, and that's as simplified as you need to go. That's the whole thing. All right, guys, let's get our practice worksheet and let's do it.